are going to present FDT test, which stands for Field Density Test using sand replacement method. Before we proceed to our presentation, I'm going to introduce my group members.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zafadli Beloman Hakim. My metric number is DF19016.
Hi, my name is Shabina Fai bin Nazri with a number metric DF190131.
Hi, my name is Alia Erdina binti Muhammad Razmi. My metric number is DF190135.
Hello, I'm Elina Dira binti Ibrahim, DF190114.
Hello, I'm Nur Aminah binti Mazin, metric number DF190119.
So, don't waste any time. Let's go!
Hello, today I would like to introduce about field density sand replacement method. In the most specification for earthwork, the contractor is instructed to achieve a compacted field density unit weight of 90 to 95% of maximum die unit weight determined in a laboratory by either the standard or modified practical test. Okay, this is a specification for relative compaction, which can be calculated based on lab dry density and in situ density of soil. The specification for a compaction based on relative compaction or on a relative density is an product specification. The contractor is expected to achieve a minimum dry unit weight regardless of field procedure adopted. Sand replacement method cover the determination in situ of density of natural or compacted fine and medium grain soil for which a sand puring cylinder is used in conjunction with replacement sand. This is suggested that this method to be applied to layer of soil not exceeding 150 millimeters in thickness. Okay, for objective of this experiment can be determined the in situ density of natural or compacted soil using sand puring cylinder.
I'm gonna sharing a little bit about the background study of field density test by using sand replacement method. A soil compaction test uses one of several methods to measure dry density and moisture content of soil in place. One of the uses method is the sand replacement method. The sand replacement method is used to measure in situ density of natural or compacted soils by using sand pouring cylinder. The procedure, materials, equipment, and specification of this test is based on Indian Standard IS 2720 Part 28. The apparatus of this test consisting of sand pouring cylinder with pouring cone at its base. There is a shutter between the cylinder and the cone. The cylinder is first calibrated to determine the bulk density of sand. Next, from the weight of the sand taken to fill the hole, the volume of the hole also can be determined. And lastly, the bulk density of soil is calculated, and after determining it, the moisture content, the dry density, and air voids also can be established. For the good results, the sand used should be uniform, dry and clean, passing on 1 mm sieve and retained on a 600 micron sieve. It is important of using specially graded sand because it is using for calculation that it is important to have a constant density throughout the sand. If the sand containing different densities was used for the test, it would give a different volume of excavated hole than the actual volume. Moreover, the sand should consisting of dry, clean, free-flowing particles and not degrade under repeated use. Other than that, it is also important of not losing any soil from excavated hole during the sand replacing method. It is because the sand replacement method actually used to determine the volume of excavated soil. The density of the testing soil is determined by dividing the weight of excavated soil by the volume of excavated soil. Therefore, loss of soil might alter the result. Furthermore, the sand replacement test method is also used to determine the in-place density of compacted soil in order to compare it with the designated compaction degree. Hence, it specifies how much of the compaction of soil close to the designated compaction degree. And last but not least, this test is significantly important and it has been widely used in various construction project sites. There are pros and cons of sand replacement method for compaction testing. The pros are: first, accurate and reliable; second, ASTM standard method, ASTM D44682; third, does not require expensive training; fourth, no licensing and permitting required for use; fifth, equipment and materials are not hazardous; and lastly, equipment is cost effective. And the cons of the sand replacement method for compaction testing is: test may take 30 minutes or more to complete; second, heavy equipment in the area may need to pause operation briefly; and lastly, all excavated material must be carefully recovered.
Okay, what apparatus that we use for the experiment? First is cylindrical calibrating container and sand pouring cylinder filled with a uniformly graded sand passing through number 20 and retained at number 30 sieve. Next is a density plate with a center circular hole of the diameter equal to the diameter of the pouring cone. Digging tools, balance sensitive, spoon, metal tray, brush, moisture container, and last but not least is oven. Okay, next for the procedure, there's a two-part for the sand replacement method. First is a calibration of the apparatus, and second is a measurement of the volume of the hole. Calibration of the apparatus, first is the sand is pouring, cylinder is filled with a weighed sand, and the calibrating container is placed below the sand pouring cylinder and the shutter is open. Next, the sand fills the calibrating container and the cone. Next, the pouring cylinder is lifted from the calibrating container and weighed. Next, the sand pouring cylinder is again filled with sand and within 10 mm of its top. Next, the sand is allowed to run out of the cylinder and equal to the volume of the container and the shutter is closed. Next, the sand pouring cylinder is then placed over a plane surface and the shutter is open and the sand run out the cylinder and fill the cone. Next, the shutter is closed when no further movement of sand take place. The cylinder is removed and the sand formerly filled the cone is collected and weighed. Next, the unit weight of the sand is determined as under the initial weight of cylinder with sand is minus by weight of the sand in the cone only and minus by the weight of cylinder after pouring sand into a cone and the container and divided by a volume of the container. Okay, for the part 2 is a measurement of the volume of the hole. This first is a tray with a center hole is placed on the prepared ground surface which have the clean and properly leveled. Next, the hole about a 100 mm diameter and 150 m diameter deep is excavated in the ground using the hole in the tray as a pattern. And next, the soil is removed and carefully collected and weighed. Next, the sand pouring cylinder is placed over the excavated hole and the shutter is open and the sand is filled in the cone and the hole. Next, when the sand stops running out, the shutter is closed and the cylinder is removed and weighed. Next, the volume of the hole is determined by the weight of the sand filled in the hole and the unit weight of sand, which is the formula is the weight of the cylinder and the sand before the pouring into the hole, minus by the weight of the sand in the cone only and minus by the weight of the cylinder after pouring sand into the hole and divided by the unit weight of sand as found from the calibration. Okay, next, the bulk unit in situ soil is determined from the weight of the soil excavated and the soil and the volume of the hole. Next, the wet density of or bulk density of soil is computed as the weight is minus by a volume. Next, after determining the water content of soil, the dry density of soil is computed as a unit weight is divided by 1 plus mc. Okay, for the sand replacement method procedure, first calibration of a cone apparatus has been done. Second, the sand cone apparatus of non-density sand is weighed. Third, the density of clay is set on a level clean test. The fourth, the soil 150 mm deep with a 100 mm diameter as a density plate hole is dug out, or the loose soil is cleaned out and the test hole with a brush and spoon. Number 5 is all the excavated soil is collected and weighed. And number 6, the sand cone apparatus is inverted over the density plate and the valve is open to fill the hole with a sand. When the sand stops flowing, the valve is closed and the apparatus is removed from the test hole. And for number 7, the sand cone apparatus with a remaining sand is weighed. Number 8, the sand is collected as much as possible from the hole. And last but not least, a sample of the excavated soil is put in the weight, moisture content and placed in the oven for the water content determination.
Now, I'm going to explain the result and discussion for field density test. All the results are taken from a past project that has run the FDT test. So here we can see the result obtained to calculate the bulk density of soil. Now, the gathered result to calculate moisture content, dry density, and relative compaction of the soil. Now, for the discussion part. The type of material that used was the standard sand that was allowed by British Standard 1377.9 of soil testing for using to conduct field density tests using sand replacement method. Based on the test report, the value of bulk density is already given, which is 1.3 megagram per meter cube. Actually, the SI unit that is used for density is kilogram per meter cube, but since the data use megagram per meter cube, so we just take weight. The field density that has been done at 2 different locations with different condition of soil. So before we go to the result, all the calculations have been done referred to the formula. So from the result, we can see that test number 2 shows higher dry density with a value of 2.06 megagram per meter cube compared to test number 1 with dry density of 1.98 megagram per meter cube. For the moisture content, test 2 shows the higher presence of water in soil with a moisture content of 8% compared to test number 1, which is 4.2%. The maximum dry density is taken from the compaction test done on the soil sample of same soil description, and the value of the maximum dry density for both tests is 2.09 megagram per meter cube. The calculated result of relative compaction for both tests are greater than 90%. The dry density of soil at construction site should not less than 90 to 95% of the maximum dry unit weight of the soil sample as computed in laboratory.
Today I want to talk about my policy, conclusion and recommendation. Okay, for the conclusion, we can be really from the overall result of analysis of density field density test by sand displacement method, it can be concluded that the sand displacement method was determining the in-situ density of natural or compact soil using the pouring cylinder. The relationship that can be established between the dry density with non-moisture content. Okay, based on the result obtained, it can be concluded that the density test that have been run has met the requirement needed, where the relative compaction for both tests are greater than 90% of the maximum 90% of the maximum dry density as computed in the laboratory. Therefore, the construction site does not need to recompact. Okay, the dry density of the compact soil of pavement is a common measure of the amount of the compaction achieved during the construction. If we know about field density and field moisture content, so we can conclude the dry density. The field density test is important as a field control test for the compaction of soil or any other pavement layer. If dry density at the site fall below the specification of testing, then the site has to be recompact in order to reach the quality margin of the test specification. Okay, the recommendation. Why recommendation? Okay, because we might for the produce more clear and reliable result. Okay, we have four recommendation. First, the number of in-situ tests has to be increased so that more data can be obtained and increase the accuracy of the analysis. Second, additional location may be selected for more tests to be carried out. This is because used to as subgrade will be different, therefore the result of the in-situ density test will be more general. The moisture number 3, the moisture content may play an important role of the analysis. Is because if the moisture content on the ground can be controlled during the test, so the result will be more accurate. 4, if the test can be carried out within a short period, so the moisture content of the ground not very much, then the accuracy of the result will be higher. Okay, that's all.
Thank you!